afternoon friends, I welcome you all in this session. As you are aware, in previous session we discussed couple of questions related to measures of central tendency and measures of dispersion. So, we will continue our exercise and let us look at question number 21. We want to know whether these statements are true or false. So, let us look at statement number 21. The interquartile range is based only on two values taken from the data, though I did not teach you what is interquartile range. So, let me skip this for the time being, but this statement is true. You will come to know it once I teach you interquartile range. So, the standard deviation is measured in the same units as observations in the data set. Yeah, this is true, this is completely true, right. A fractile is a location in a frequency distribution that is given proportion of the data lies at or above. Is this correct or not? Is this true or false? 23 is false. There is nothing like above or at that particular data point, right. The variance, like the standard deviation, takes into account every data point in the data set. Yeah, this is true, because once we calculate standard deviation, we just take a square of it, right. So, it is one and the same thing. The coefficient of variation is an absolute measure of dispersion. Is it absolute measure? No, it is a measure of dispersion, but it is relative measure, right. So, this is false. This 25 number statement is false, right. The measure of dispersion is most often used by statisticians as the standard deviation. Of course, standard deviation is the most useful measure of dispersion. So, this is true. Let us look at this one. One of the advantages of dispersion measure is that any statistics that measures absolute variation also measures relative variation. No, it is not like that. So, this is false, right. One disadvantage of using the range to measure dispersion is that it ignores the nature of variation among most of the observations. Yes, this is true, it ignores. Let us look at next question. The variance indicates the average distance of any observation in the data set from mean. Is it correct or not? Yes, this is true, right. What is variance? This is, you have got standard deviation, you have got mean, isn't it, and this is, if you take a square of this standard deviation, it becomes variance, right. So, variance indicates the average distance of any observation in the data set from the mean. This is true. Now, every population has a variance which is signified by S square. Is this correct? Every population has a variance, yes, but what is this? This is the symbol for sample variance, right. So, this is false, right. So, what would be the correct answer for this? This would be this, right. According to Chebyshev theorem, I did not teach this one. So, let us skip this question as well. You can skip this also, because I did not teach interquartile range. It is possible to measure range of an open ended distribution. No, this is false. Point number 33 is false. The interquartile range measures the average range of the lower fourth of distribution. Is this correct? Again, let us skip this, right, because it is on interquartile range. When calculating the average rate of debt expansion for a company, the correct mean to use is what? Arithmetic, weighted, or geometric mean? It would be geometric mean. So, C part is correct. Why C part is correct? Whenever we measure any change in rate over a period of time, then the correct measure would be geometric mean. The mode has all the following disadvantages except one. So, a data set may have no model value, it is possible. Every value in data set may be a mode, yes, it is also possible. A multimodal data set is difficult to analyze, yes. The mode is unduly affected by extreme values. No, this is an advantage. So, this is the correct answer for this particular question. Let us look at 37 number question. What is the major assumption we make when computing a mean from grouped data? All values are discrete, is it? Every value in class is equal to the midpoint, no value occurs more than once, or each class contains exactly the same number of values. So, what is the correct answer to this question? Question is, what is the major assumption we make? The major assumption we make is this, right? Every value in a class is equal to the midpoint. Let us look at this question. Which of the following statements is not correct? Which of the following statements is not correct? Some data set do not have means, is it possible? Calculate the mean, calculation of mean is affected by extreme data values, yes, this is correct, is not it? A weighted mean should be used when it is necessary to take the importance of each value into account, and all these statements are correct. Point number 38. So, this is not correct. Some data set do not have means, no, all data set will have mean, right. Which of the following is the first step in calculating median of data set? Average of the middle two values of the data set, array the data. So, the most important is this, you need to array the data in ascending or descending order, right. Let us look at this one. Which of the following is not an advantage of using a median? Not an advantage, right. Extreme values affect the median less strongly than they do the mean. A median can be calculated for qualitative description, yes, we can calculate. The median can be calculated for every set of data, even for all sets containing open ended class, this is the one, right. The median is easy to understand, and all these are advantages using mean. So, we have to see which one of them is not an advantage. So, this is not an advantage, right. Let us move on to next question. Why is it usually better to calculate a mode from grouped data rather than ungrouped data? So, the ungrouped data tend to be bimodal, is it the reason that we calculate median of group data? The mode for the group data will be the same regardless of skewness of distribution. Extreme values have less effect on grouped data. The chance of an unrepresentative value being chosen as the mode is reduced. So, this is the answer to this particular question, right. So, why we use grouped data for calculating mode? Because the chance of an unrepresentative value being chosen as the mode is reduced, right. In which of these cases would the mode be most useful as an indicator of central tendency? So, which is the most important one? Every value in data set occurs exactly once. Just read this one very carefully. In which of these cases would the mode be most useful? Mode be useful as an indicator of central tendency. Every value in data set occurs exactly once. All but 3 values in data set occur once. So, all values will occur once except 3, and those 3 values occur 100 times each. All values in a data set occur 100 times each. Every observation in data set has the same value. So, what would be the answer out of these 4? The answer would be B, right, because there is a data set in which except 3 values, all values are occurring just once, but these 3 values are occurring 100 times. Okay. So, it is a case of multimodal example. So, which of the following is an example of parameter? I have talked about statistics and parameter. So, which one here is parameter? Is this parameter? No, this sample mean. What about this? This sample size? Yeah, this is population mean. So, this is the answer, right. Let us look at this. Which of the following is not a measure of central tendency? Not a measure, right. Mean, yes, it is. Median, mode, mean, of course these two are types of means. So, all these are measures of central tendency. So, the answer is E. When a distribution is symmetrical and has one mode, the highest point on the curve is called symmetrical distribution, means a distribution which is like this, right, symmetric, is not it. So, what would be the highest point called? It would be called range, mode, median, B and C, B, C and D, but not A, is not it, B, C and D, right. So, mode, median and mean, because for a symmetric distribution all these will be same, right. When referring to a curve, the tails of the left end, what would be the curve would look like this, is not it. So, this is left tail, right. So, when referring to curve, the tails of the left end, it would be negatively skewed curve, right. So, there is no, so all these are not the answer. So, none of this is the answer, because this is negatively negatively skewed curve, right. Disadvantage of using the range as a measure of dispersion include all the following except is heavily influenced by extreme values. Yes, it is. It can change drastically from one sample to the next. Yes. It is difficult to calculate. No, it is not difficult to calculate. It is very easy to calculate, right. So, the answer is this. Why is it necessary to square the differences from mean when computing the population variance? Is not it? What we do? We take x minus x square, x minus x bar whole square. So, why do we do this square? So that extreme values will not affect the calculation. Is that the reason? No, this is not the reason, because it is possible that n could be very small. No, this is also not the reason. Some of the differences will be positive and some will be negative. So, this is the answer for point number 48. C is the answer, because some of them will be positive, some of them will be negative. So, this negative term would become positive. Since I did not teach you this also standard score, let me skip this question, let me skip this also. So, I will not cover these two. Which of the following is an example of relative measure of dispersion? Of course, coefficient of variation, is not it. So, answer to 51 is C, right. Which of the following is true? The variance can be calculated for grouped or ungrouped data. Can we calculate? Yes, we can calculate, right. The standard deviation can be calculated for grouped or ungrouped data. The standard deviation can be calculated for grouped or ungrouped data, but the variance can be calculated only for ungrouped. No, it is not like this. So, for 52 the answer is this. A and B but not C. Just see why not C. The standard deviation can be calculated for grouped and ungrouped data, but the variance can be calculated only for ungrouped data. No, this is not correct. We can calculate variance for ungrouped data as well. If one were to divide the standard deviation of a population by mean of the same population and multiply this value by 100, then it would be what we are calculating. If one were to divide the standard deviation of population by mean, so this is this, right, standard deviation by mean, right, of the same population and multiply this value by 100, then what it becomes? Population standard score, population variance, population standard deviation, no, all these are not correct, it is coefficient of variation, right. So, D is correct answer. How does the computation of a sample variance differ from the computation of population variance? Though we have seen couple of examples on this, we will look at population parameters as well, right. What are population parameters? Population mean, population standard deviation, population variance, right. So, how the formula changes from sample to population? Mu is replaced by x bar, n is replaced by n minus 1, n is replaced by n, right. So, capital N is replaced by n. So, what is the answer? A and C but not B, A and B but not C. So, this is not there. So, the correct answer is E, right, this is the correct answer. The square of the variance of a distribution is what? The square of variance. What is variance? Variance is this, is not it? So, square of variance of a distribution is what? Standard deviation, mean, range, absolute deviation, A and D. None of this, there is none of this, right, because there is nothing like, of course, mathematically you can calculate, but variance square is nothing, right. It is the standard, it is the square of standard deviation becomes variance, right. I did not teach you anything about Chebyshev theorem. So, let us skip this question. If a curve can be divided into two equal parts that are mirror images, it is called symmetric. If it cannot be divided in this way, it is skewed, right, or unsymmetric. Okay. Let us take this one. The symbol x bar denotes the mean of what? Population or sample? Sample, right, and mu denotes what? The mean of population, is not it? Assigning small value consecutive integers to midpoints during calculation of mean is called what? Assigning small value consecutive integers to mid values when we calculate mean or median, especially mean, then what is that called? It is called coding, right. So, when dealing with quantities that change over a period of time, it is better to calculate what mean? Geometric mean than arithmetic mean. Okay. So, this is the last slide so far as exercise is concerned. If two values in a group of data occur more often than any others, the distribution of the data is said to be what? There is a data set in which only two values are occurring more than others or more often than others, then that would be a case of bimodal, right, bimodal, right. The extent to which values in a distribution are grouped together is a measure of what? The extent to which values in a distribution are grouped is a measure of what? Dispersion, right, is not it? In a frequency distribution, the median is 0.05 fractile, right, because half of the data values are less than or equal to this value. Let us look at this question. The difference between the values of the first and third quartile, let us skip this also, though this the answer is interquartile range. The measure of the average squared distance between mean and each item in the population is what? The positive square root of this is this variance and this is standard deviation, is not it? This variance, right. The expression of the standard deviation as a percentage of as a percentage of mean is what? Its coefficient of variation, right, coefficient of variation. The number of standard deviation units that an observation lies above or below mean is called what? Yes, though I did not teach you, so let me skip this for the time being. Fractile that divides data into 100 equal parts are called what? I have taught you that if you divide data into 10 equal parts, it would be decile, 4 equal parts quartile, 100 equal parts percentile, right. So, percentile is the answer over here, right, percentile, right. So, with this let me finish this particular exercise and we will move on to next topic, which is the location of extreme outliers. How to, in fact, I have talked about outliers, we have talked about extreme values when we were calculating mean, is not it? We have always said that the drawback of mean is that it is highly affected by outliers. So, what are the outliers? How to calculate outliers? So, there are a couple of ways in which you can calculate outliers. So, one of the methods is its Z score or standard score. This score will give you whether an observation is an outlier or not. So, to compute this standard score, we will have a mean, we subtract the mean and divide the standard deviation. So, whatever is your data value, right. So, let us say x minus x bar divided by standard deviation. So, this is nothing but Z score, right. Okay. The Z score is the number of standard deviation and data values away from the mean. Okay. So, this is your distribution, let us say this is mean, and if I want to calculate how far this particular data point, let us say x 7, let us say there are 10 data points x 1 to x 10, let us say this data point is x 7. So, how far this is from mean? So, that would be calculated in terms of Z score. Now, here is the answer to what question I asked in the beginning, how to find out outliers. So, the data value is considered an extreme outlier if its Z score is less than -3 or more than +3. So, any value more than +3 and less than -3 would be an outlier, right. So, any Z value, right, Z value more than this and Z value less than this would be an outlier. The larger the absolute value of Z score, of course, the farther that point is from the mean, right. So, let us say this is your distribution and Z is equal to, let us say 1 and Z is equal to 2. So, Z is equal to 1 is this. So, this is the point, let us say P1 and this is P2, right, this is Z is equal to 2, right. So, what we have said, larger the Z value, farther the data. So, this point is far from mean value compared to this point, right, P1 point. So, this x minus x bar divided by S, this is for sample, right, we are talking about sample, right, this is sample standard deviation, right, this is sample mean, this sample data point, right. Similarly, you can calculate it for population also, right. So, how it would change, x minus mu divided by standard deviation, right. Let us look at an example wherein we have calculated Z score, right. Suppose the mean math set score is 490 and standard deviation is 100. Compute Z score for a test score of 620. So, there is let us say students have appeared in an examination and the mean score of that examination of all those students who appeared is what, 490, right, this is 490, right, and standard deviation is, so this mean standard deviation is 100. So, how to calculate Z? You just put these values, right. So, this is x is 620, is not it. So, compute the Z score for a test. So, how far a student who scored 620 marks away from mean is 1.3 value, right, or 1.3 standard deviation above the mean. Why above the mean? Because this value is positive value. It means where this point would be, let us look at this. So, this mean is what, 490, right, 490. So, let us call this as this is your mean x bar 490 and S is equal to what, S is equal to 100, right. So, this point would be somewhere here, right, 620 marks, is not it. So, all points towards left hand side of the mean would be less than 490. So, this is how you can calculate Z score. Let me tell you a little bit about shape of the distribution. Whenever you have any data set, it is good to draw a distribution so that you will come to know whether data set is normal or not. So, if your data are normal, then the shape of distribution would be like this, a bell shaped curve, right. So, this is the point where mean, mode and median all are same, right, in a bell shaped curve. So, the both these parts are equally divided, right, 50% this side and 50% this side. Now, this is positively skewed curve, right. So, this is the tail of this distribution, right. So, this is positively skewed curve, and in a positively skewed curve keep in mind that mean will always be greater than median, right. So, this is mean, this value is mean, this is median, and negatively skewed just opposite, the median would be more than mean. So, this is the median, this is median and this is mean, right. So, you can have either symmetric or asymmetric distribution, right. If it is asymmetric, it would be either positively skewed or negatively skewed. So, let us quickly take this example. So, you can solve this example using MS Excel. So, you have been given house prices. So, let us say this is 100,000, 100,000, 300,000, 500,000, 2,000, right. So, we just want to find out mean, mode, median, minimum value, maximum value, standard deviation and so on. So, just go to tools, data analysis, right, descriptive statistics. So, as I said, what is this descriptive statistics? It describes the characteristics of a person, group or organization or a data set, right. So, in this case you can select this particular range from A11 to A6 and then you will get the answer. So, mean is this, median this, mode this, standard deviation is 800,000, right. So, this quite quite a large standard deviation. Range is this, of course, from minimum and maximum you can find out range, and there are 5 data points, right. So, this is the output from Excel sheet and this is the output from Minitab. So, you will get the same answer, right, mean, standard deviation, minimum value, right, maximum value, median and range, right, mode, skewness and kurtosis, right. So, let us look at couple of measures of population, though we have already seen 1 or 2 examples on measures of population. So, what are the measures of population? The same which were there in case of measures of sample, right. So, the measures of populations are called first of all parameter, right, and measures of sample are called statistics, right. So, important population parameters are mean, variance, this and standard deviation, right. For sample, what those were? Mean, this and this, isn't it? Let us find out mean of the population. So, this is very simple, similar to what we did in case of sample mean. So, you have just summation of all the data points divided by population size, you will get population mean, right. If you look at variance, variance is summation of I ranging from 1 to n. So, you have got these xi data points, this is population mean. How to calculate population mean? We have just calculated in previous slide. So, xi minus mu whole square divided by population sample size, right. In earlier case this value was small n minus 1, right. So, this is population variance. So, if you know variance, you just take root of it, it would be under root of it would be standard deviation, right. So, this is the same thing in next slide. So, the most commonly used measure for population parameters is standard deviation, right. So, the most important or and most useful parameter to measure population dispersion is standard deviation. It shows variation about the mean, is the square root of the population variance, this is what I said, has the same unit as the original data, right. So, this is population standard deviation. So, this is the difference between these two, right, sample statistics and population parameter. Now, before moving on to the next session, let me summarize what we did today. In today's class, we have seen several concepts related to the dispersion of central tendency and dispersion of measure. We have also seen how to calculate population parameters, namely population mean, standard deviation and variance. I hope that the exercise which we have undertaken in last session and in this session would really help you in making your concepts clear as far as business statistics is concerned. So, with this let me stop here. Thank you very much. We will have some more lectures about numerical descriptive measures in next class. Thank you very much.